Hi, Nikolai.
Hi, Mark. Hi. It's been a while.
I know.
Yes. I couldn't join for a while because there were too many things, but some of them are quite exciting.
Good. Want to
Yes.
share?
Yeah, actually one thing that is particularly exciting, we have this so in Sweden there's a personal data protection authority.
Mm-hmm.
I don't know what would be the equivalent in the US, but they have a sandbox, a regulatory sandbox for evaluating digital technologies and so on. And they're looking now at pets, and they chose our ongoing collaboration with Ericsson and Volvo
Mm-hmm.
Trucks
Mm-hmm.
to evaluate. Where basically there the story is that Volvo they collect a whole lot of data on their trucks. They cannot process all of it on the truck. Obviously,
Yeah.
that's too much, and so they would like to process it on the telecom infrastructure.
Mm-hmm.
Uh, but then that exposes let's say, this data and the workloads that they use to process it to the mobile operators, because the mobile operators would be providing the service.
Right.
And so the idea is to run these workloads in trust execution environments so that this basically becomes just an extension of the truck. The
Right.
the mobile operator just is blind, just offers this this compute capability in the trust execution environment, and then
Yeah.
Volvo just processes their data and doesn't need to be bothered about this data leaking or personal data leaking somewhere else. And so it's kind of exciting. Also, talking to lawyers, explaining this technology to lawyers is it's exciting. But they also are very technical. They have some very technical people on the team. But this is, I think, a good, let's say, assessment from a regulatory point of view to back up those claims about, yeah, confidential computing helps with GDPR, to actually add some substance to that.
Right.
So that's what has been keeping me busy. And actually now in the coming weeks we'll also be discussing the governance aspects and everything that we've been discussing in this group.
Oh, good.
That will be very
Well,
exciting. And also I'll come back with questions.
please bring everything you learn into the forum.
Yeah.
I'm usually give people a minute or two or like a few minutes to join. Given this is our last meeting before the informational draft is submitted, I sincerely hope we're going to get some participation today, but we'll see. Maybe it will be just you and I.
Yeah,
Uh,
here's a link in case you're interested. Probably you can translate it with some tool. But
hmm,
yeah, definitely I simply didn't have the bandwidth to convert all the questions that we got there and will get there, because they're really relevant to this forum. But I will need some time to process this, and I'll
yeah,
bring a lot of good questions.
yeah. Well, so the pitch that I have settled on for how, and I'm actually gonna, I was asked to present at Global Platform
Mm.
in a November meeting, and I can't go there in person, unfortunately. But so anyway, but there is a pitch that I've now made to multiple places around this workload identity stuff, and it really it comes from the fact that these forums that we have in IETF and the consortium, they do not really have customer representation. They have engineers reasoning about what customers might want. A
Mm.
lot of that is not rooted in the customer's reality, but in
Yeah.
engineering reality. And what's missing, if I were to put it succinctly, is what I call relying party empathy, like
Hmm.
understanding what it takes to manage your enterprise, specifically from a controlling who has access to what resources,
Yeah.
where data center people manage one part of your estate, which is the hardware estate, and then engineers and software developers control the software part of your estate. And then there are acquisitions, and there are SaaS vendors and contractual
Yeah.
obligations. So you have the regulatory part of your not really a state, but like the sort of the regulatory part of people who are tasked with ensuring that you meet your various obligations, right? So, we are moving into a world where because of most data is exchanged between workloads, not between humans and workloads.
Yeah,
Right?
exactly.
But we've kind of solved with limited success, but with some success, the human identity problem, right? And now we
Mhm.
even have passwordless, whatever. What we're missing is, for one, we need to harmonize human and non-human identities, so that's going on. But if you further do not harmonize legacy workload versus confidential workload, you stand no chance,
Yeah, exactly.
right?
Then you really need to deal with it. And again, this is we see it in this forum as well, because this is one of the questions that I got and will get again next week. It's like, okay, so how do you manage the identity of the workload that is processing? How can you be sure that it is the workload that is intended? Like,
Yeah, yeah, yeah,
and
yeah.
this is where the
All
fits in.
right, so let's talk about that so let me share. So I'm going to put the link to the document we are reviewing in the chat. And again, I really was hoping for more people, especially the key people like Hank
Yeah.
and Yogesh. I don't know what's going on with them. I'll have to ping them. Okay, so if you click on that, you will be able, and I'm going to share it in my screen so we can look at it together. Um, all right, you should be able to see my screen now. So again, I am happy to start doing edits and then do a commit the results. So part of that is this, and part of that is if you scroll down, I put a bunch of, well, I include them by name, but I identify the number of options, and there are swim lane diagrams or sequence diagrams for the various ways in which this can be accomplished.
By the way, I want to just say, right now I'm in the framework of the sandbox. I'm working on a glossary,
Mhm.
and I will use some of these definitions directly in that
Okay,
glossary
great.
with the regulators, because
Yeah.
yeah, glossaries are difficult.
Okay. Cool. All right. So anyway, so let's start reviewing here at the introduction and just move on to like
Yeah.
convention. So the definitions are mostly set, but I added a couple just are specific to this draft. And I mean, again, we'll whatever sticks in this draft, we're going to move back into our documents, like our definitions document and the reference architecture. But this is probably the most current proposal that we have, or it's supposed to be. So let me know if there's anything let's just start with this. If there's anything you would like to change about this opening statement, and then we'll
Yeah.
move down.
I'm reading through. So actually, one thing that immediately popped up. So confidential. So we define the relationship between confidential computing and trusted execution environments. How do you see that? Is confidential computing is the act of computing in a trusted execution
Well,
environment?
there is a
What is
definition.
it?
Confidential computing is the act of, right. If you have confidential computing, then your workloads execute in trust execution environment.
Yeah, so it's kind of the act. This because it just struck me that it seems to be obvious, but then what is the
Yeah.
relation? But let's put it as the
Yeah,
act.
your computing is
It's
confidential. The act of computing is confidential if
exactly the
you
act of
use
computing.
utilize, yes.
Mhm.
So you guess we're going through the motions of reviewing the latest draft, and I'm hoping to get through the text very quickly and then focus on the sequence diagrams.
Yeah, that's fine. Are you in a standard way of ITF in terms of sequence diagram? Did you prepared in
So we
the
haven't figured this out yet, but I drew them at the mermaid language,
okay?
and we will need to figure out. And again, the time is very short. We have 6 days until the
Yeah,
submission deadline. So we need to get the for one, this doesn't compile. Every time I make a commit, it gives me back and says all your jobs have failed. So I need someone with the experience of doing that to do it, or I will have to figure it out myself, but I've never done it. And the second thing is we need to figure out how to convert our various pictures into ASCII format.
Okay. Let
Yeah.
me check. You have done it in Mermaid, right? You said?
Yeah. So you'll see in here, I'm basically put all the various pictures. There are 5 sequence diagrams.
Mhm.
There are these 5 .sd files. I came up with the .sd extension, but it stands for sequence diagram. So if you click on it, that's a sequence diagram. You can literally paste it into Mermaid and it'll render it for you.
Okay.
Okay, so going back to the review of the text.
Yeah, I think it reads well. Just a couple of, from my point of view, nits is I think the word required trust is, I think, extra in the last sentence.
What do you mean?
Yeah.
The standard practice
the-
to establish required trust in the operating environment. The last sentence of the first paragraph.
Yeah.
I don't think it adds anything.
Yeah, you are right. I think
I see.
I added this paragraph and I agree that it should be standard practice to establish trust. Yeah.
Yeah, exactly. Yeah, and then I would also simplify it. It's through remote attestation, but that's just my style. I used to. I like to just
Okay,
branch
yeah,
it.
no, yes, okay. So we will.
We can remove just establish. Yeah.
Establish trust.
Yeah.
Exactly.
Yeah.
And I would just say through remote attestation.
Yeah,
just
awesome.
more direct.
Yeah.
Cool.
I don't know how to start with functionality because I haven't really tested. The thing is, I only installed it.
Yeah, the next
All right,
sentence
so
is
now we're
fine.
going to go into the definitions.
Yeah.
And so what we've done there is some of the definitions are effectively unchanged from Whimsy and Rats, but I've added a couple. So workload is the same. Well, that's
Okay, I guess let's say the ones that are the same, we should not touch them. We
Yeah.
should not aim to improve them. The ones that are so if you could just point to the ones that are different, that are not from Whimsy, then we should focus on those because we
so
should
there
not
is
touch
this
the ones
word
that are.
stable.
Exactly.
That is an interesting adjective, which I use it here. I usually like to use all terms like after I define them, and in this case, just for historical reasons, the order has been reversed. So identity and credential, they have not changed.
Yeah.
Okay.
Because also already in the introduction you mentioned can obtain
Stable.
trustworthy, stable, and that was like it clicked. Like, what is stable? Is it
So
like
there we
this?
go. So there is
Yeah.
stable workload identity.
Yeah. Okay. Good.
So again, we can. Here's the thing: is this is kind of a workload identity. So there is a workload identifier already uses the word stable, and then workload identity doesn't, and then credential doesn't. But what makes workload identity stable is this: it's considered stable if
if it remains constant. Yeah. Constant in the sense of unchanged, right? Or if it persists in the face
correct.
of
So the payroll application is payroll application. It may be version 4, version 5, but it's still the payroll application.
It does this, does the same thing. Stay within the policy of what.
So in this case,
I wonder if within is the right word, or if it stays compliant to the policy. Because within, I guess,
Complies with.
complies with the policy.
so
Because within would mean some sort of policy
Within to me, this was like version 4 to version 5.
Exactly. You're thinking
That
of
one
a
was thinking
fork.
about like a range, but like
Yeah.
really complies with policy is more generic.
Yeah, with the policy of what? Yeah, I would skip in question, but like of the
Yeah.
target.
And again, what
software and hardware.
constitutes a bound credential? That's another term that is not in our documents today, but I added it.
It's considered bound. Okay, it's also an a adjective. It's considered bound if it's gonna be
Let me just kind of check this for me.
secret credential key that only
Is
works.
it like built on the floor?
So here's the thing. For practical reasons, it is not possible for every workload instance to create and certify its own key. That's just not going to happen. So in some cases, like in horizontal scale out, for instance, you generate one certificate, and then every workload gets the key for that certificate, right? So in that case, you have to retrieve a key, but it still remains bound, because unless you're that, if everything's properly set up, unless you're that workload instance, you're not going to get or instance of that workload, you're not going to be able to get that key. That's why bound here is like I make that clarification for that reason.
Yeah, this is good. I just for readability, I would move the part in brackets to a separate sentence.
Well, I can just put comma and open the brackets.
Okay, yeah, that would be better.
Because usually you do not create examples inside of definitions. Like you don't define by example. Okay. Workload owner, I haven't defined yet, but it's a it's an entity that will figure. So let's come back to that. Just put a pin on this.
Yep.
Because workload owner is effectively manifest by actions of the control, like control plane of some kind. Okay, so available options. Let's just review that. And we'll need to move quickly because we only have an hour, and this is our literally last in-person meeting before this gets submitted. So let's just pick up the pace if possible.
Right. So which line are we looking at? 146?
144.
44. Okay.
So
Can
this
you scroll?
paragraph now.
Yeah, okay. Yeah, I think that's fine. Should we limit this to exactly 2 items, or we don't want to to open it up for more extensions?
No, I mean,
in the future,
we can always do another version of the draft later. This is just to this is correct at the time of being written. If somebody wants to comment on it, we'll this is kind of an opening salvo, right?
Okay.
So because we defined stable, I'm going to capitalize S. So
Exactly,
146 now.
Okay, so whenever you use a term that you've defined, you capitalize it, right? Okay. Vouch for or consider trustworthy? Because
no, they're entities. Entities vouch by providing reference values.
Okay, so they vouch for workloads and configurations.
Reference values. This is hardware and software. And
okay, yeah. So they vouch for the reference values. Okay.
Yes.
Okay, here's a kind of this is the example, right? It's typical enterprise table reception. I wonder if do we need this? I mean, I see that you want to provide a clarification, this historic thinking about the station results.
Yeah, because they're examples of what exists: hardware manufacturer, firmware and software versions, etc. And that we need to move away from.
Yes, exactly.
This is why, like, this is not a normative part. This is really a discussion.
So okay, so we can just
What was it we're
okay.
trying to accomplish? And rats have been doing things in a way that, you know, I don't want to criticize rats too much. I'm just simply saying historically rats has done this thing.
Because I would just say, like, you know, in a final version, I would rather skip this, because then it's like depending
yeah,
on when
yeah.
rats and so. But for communication at this point, I think it can be useful.
Right.
Yeah. 'Cause- yeah.
So, and again, this is going to go into the options that we have in sequence diagrams
Exactly.
before.
This is different.
All right. So, so within the RATS architecture, we can accomplish these options in one of two ways. So again, this is important to state because I'm not changing the RATS architecture. The RATS architecture doesn't change as a result of this. Because also RATS architecture is not a specification. It doesn't say, you know, send this in that format or whatever. It simply says there's this thing called attestation results. So within attestation results, I'm basically saying one option is in the attestation results, you have everything it needs. Oh shit, what did I just do?
Oh,
No, I don't need that.
no.
No, what I meant to say, everything it needs could probably be changed, both credential and the credential key. Rather than saying everything it needs, I think it's too vague.
Yeah, exactly.
Okay, so we're just repeating the two things that it needs.
I think it's good to be explicit.
That results encoded. So under 2, the attestation results are encoded in the entity attestation token or bespoke verifier specific format, because I don't think RATS says you have to issue an EAT.
RATS has taken the EAT attestation result EAR as one of the standards which has been adopted. So,
But are there others?
yes, there are others. So,
That's
or
what I'm
bespoke.
saying. So
Yeah.
the attestation results, again, this is within RATS to use an EAT, and it's within RATS to use verifier specific format.
Can be used by the testing workload to obtain the industry-related standard bound.
I wonder if we need this industry standard, because it again doesn't really add anything to obtain a bound credential.
Yeah.
I think we want to emphasize that to obtain a bound credential, it's up to the user to define which one.
And so utilize credential authority, because I think people understand what a certificate authority is. But if your credential authority issues, so like a spiral server, if it issues like a workload identity token, a WIT, then that's fine too. But I did never define credential authority in this document. I do not know if we should.
Well, I think it, again, it's one of those things that seems to be intuitive, but then once you start discussing it, it might not be. So I think it's better to do that.
So I'm gonna add a to-do here. And we'll do that later. Because I already say define workload identity or workload owner. That we'll get into in a second.
Exactly.
Okay, cool. So now credential authority is defined. All right, so, but this is the important thing. In either case, the detailed information of the workload's composition conveyed to the verifier using RATS evidence is mapped to stable,
stable, capitalized,
technology agnostic, business-oriented claims about the workload. This is what we're really after.
I think, exactly. I think this is the meat.
Yes.
It should be somehow really highlighted. And this is how this really departs from RATS, because RATS is very focused on technical.
Okay, so these two options can be visualized at a high level and this is a to-do here. So that will explain here for those who haven't been to a previous meeting of ours. But this in the reference architecture, this refers to this picture that we'll need to ASCII. So in one case, the workload goes to the verifier, it gives evidence, receives attestation results, and then we'll change credential issue to credential authority.
Yeah, exactly.
So I can even do it now.
This is a simple diagram. This is easy one. Yeah, I can change this one.
But this one is easy to ASCII because it's easy to convert to SVG.
Just so that Well, okay, these look like very much like those, the attestation model, passport model, background check model. Are they the same or they're different? They just look similar.
Well, the relying party in this case is not the same as the relying party in rats.
Yeah, like conceptually, but is
It's
the shape
actually
the same?
different, right? Because in either case, we're not giving attestation results to the relying party. This is different from rats.
Mhm. Okay, right.
Okay.
So
But anyway,
again,
so I'm referring to that picture, and I'm kind of, unless you have a very important comment right now, I need to move forward to
okay,
the most
let's go.
important bits.
Okay, then I will
Feel
comment
free to
afterwards if there's
comment
something.
in
Exactly.
GitHub too after this
Yeah.
meeting is over. Okay. So this is some verbiage we agreed upon earlier in these meetings, but why don't you just read them real quick? So variant 2, just again, for variant 2 is the one on the right. This is the workload goes to the verifier. Verifier itself contacts the credential authority and gives back an attestation results, including credential.
Yeah, exactly. This is very much a model that we have as well, for example.
Yeah. Okay. Right, but in this case, effectively, what's going on is on variant 2, there is an extra round trip. So at some point in time, is it? Am I even saying it correctly?
It's a bit convoluted.
So what I was trying to say is, so the workload here, like from the point of the, in fact, and I think it's variant 1 here that has the extra round trip. So in one of the variants, the workload goes to the verifier and gets back a credential. And then it goes, sends a credential to the relying party. And I think this is actually variant 1, not variant 2. So here, the workload needs to first go talk to the verifier and hope the verifier is up. Otherwise, it can't do the work. And then it basically says, okay, I get my attestation results, and I'm going to send them as a credential request to the credential authority. So that's the extra round trip. So the workload needs to do this first and this second.
Right. I mean, yeah. I think that's a bit confusing because it's, in a sense, if you consider the communication, there in the variant 2, as it is now in the picture, there's still this extra round trip. It's just done by someone else.
Well, unless, like here, from the workload's perspective, you don't know what verifier does. Maybe this is just a asynchronous library call.
Yeah, exactly. But exactly that you said it. It's from the workload's perspective.
Yeah.
So maybe you can just like make that explicit in text. So from the workload's perspective, this involves an extra round trip or an extra. I wouldn't even say round trip, but an extra, let's say, operation. Because
well, it is an extra round trip, right? Because you really have to hit a network service. So I may say network round trip.
Exactly. Okay, fine. Let's do that.
But then the user and if the port is to that user.
And again, like I would even just dumb it down because like now you explained it to me, but I would just say an extra network round trip, full stop. The first round trip is the workload exchanging evidence for attestation results. The second, or the extra round trip, is blah blah blah, getting using these attestation results to obtain a credential.
Say what? Why don't you put that as a comment in GitHub later, and then we'll take it as a PR, perhaps.
We'll do.
Okay. So there are different options that are possible because this, in fact, we're not going to cover every possible permutation because I tried to enumerate them, and some of them were just impractical. Some of them are just like, or I had some issues with them, and we can always expand and add more later. I wanted to hit the most important ones, but the pivots are correct. So either the workload generates its own credential, or a credential obtains its the secret key from a secret store.
Yep.
And we already talked about that. So that pivot doesn't change. The second pivot is where does the workload get its credential? So the first one, where do I get the credential key? This is the first thing I need. And I get it from one or two places. The second one is where does the workload get the credential? Now, it can get it from the verifier. it can get it from the credential authority, or it can get it from the control plane by the actions of the workload owner. Again, this is where the workload owner first figures.
So what can you provide a example of this control plane, like having
Yeah,
it sealed
so
to the TPM?
today when you start a container,
Yeah.
the orchestrator, the Kubernetes, whatever, goes, fetches the credential, and then puts it on a volume and mounts that volume inside the container, and the container reads the credential.
Yeah.
I also have like a word.
That
Okay, so
is
that
what I
would be
mean.
the control plane. Okay.
Yes.
Good. Mhm.
So the workload didn't have to do anything, didn't have to contact the credential authority, didn't have to contact verifier.
Okay.
It's just there, right?
Okay, so that's what you call the control plane. Okay,
Yeah.
good.
Okay. So I noticed that it is safe to receive a credential from an untrusted source, such as the control plane, because it is public. Today, we'll also retrieve the credential key from the control plane,
Which is
which is
not as
not
secure.
good.
Yeah.
So the only requirement is that the obtained credential matches the credential key. So if you get the wrong credential, somebody messes your credential, well, you're not going to be able to use it because the credential key you got doesn't match, whatever.
So in this third use case, I mean, this looks like not a very proper use case. This is like a hacky use case, right?
No, not for no, it's actually going to be very common. So if I'm using horizontal scale out, right? So I'm just gonna stand up a number of workloads in parallel. My orchestrator will get the credential, the X509 cert, and make it available to every workload. And then the workload's job is to go obtain the credential key for that workload. For that credential, sorry.
Because
So
you're
that's
saying that
not
the key is
hacky at
already
all.
there, right? Secure keys, the key is already there, right?
The key is not going to be there. The key needs to be obtained by performing remote attestation.
Okay, it's not clear how this tree is
This
getting
is in the
spanned out
sequence
actually.
diagrams. This is in the sequence diagrams.
Okay.
So here I just posit that this is how it's done, and later I explain it. We should be able to walk through them in the remaining time.
Okay.
Yeah, so this is what I'm so Yogesh, this is what I'm speaking to. It is safe to receive the credential from the untrusted source, such as a control plane, because it is public. Like everyone knows what that X509 certificate or WIT is. What you don't know is the credential key. The only requirement is that the obtained credential matches the credential key.
Okay. Okay.
Okay. So, and then 2I is this. If you're going to get strength from the verifier, there is an order of interactions that I also wanted to make clear. And again, this is because I was whiteboarding this whole Carnot map of like this matrix of different options. And the workload invokes the verifier, and the verifier collaborates with the credential authority to compute and return the credentials, returning these credentials inside the attestation results. And the second one is the workload invokes the verifier, obtains from it the attestation results, and forwards the attestation results to the credential authority inside a credential request to get the credential. Right. So that's that. Under this 2.I. So if you're going to get your credential from the verifier, there's actually a couple different ways in which it can be done. Which again, the sequence diagrams illustrate that.
There's like a directory with bots. You can also run the ones in the big
So this results, and this is the meat of the proposal. So when I presented this to a couple of folks, they're like, "This is a great idea, but how are you actually going to accomplish it?" And I figured, well, I've been stewing at this for so long, it's clear to me, but now I have to really explain it to any any party out there. What exactly do I mean? So there is a CAM. The CAM is a credential acquisition mechanism. Maybe I should just capitalize.
I think you should define it and capitalize it. Yeah, but maybe defining as well. I mean, it's again self-explanatory, but still.
Yeah, so there are credential acquisition mechanisms, some of which are listed in the table below. So there is an option A, B, C, D. There is one not applicable that I explain why. Like I'm kind of listing an option among these combinations above that simply cannot work for a certain reason that I'll get to. And then the pivots are, where do you get your key from? Key source. Where do you get your credential from? and then more detailed description of what's going on. And for them, for each one of them, I have a picture. Okay.
Yeah.
Cool.
Okay.
So in the first option, option A, is we get the key from the workload. So the workload generates its own, this is effectively means that the workload generates its own key pair. And then it gets the credential from the verifier. So the proof of possession of the credential key. So you basically send a self-signed credential key. It's included in the evidence submitted by the workload to the verifier. The verifier then contacts the credential authority to compute a credential based on this credential key and returns it to the workload instance as part of the attestation results. So it's effectively you submit your CSR into the to the verifier.
Yeah,
And
that makes complete sense.
all right. So
I think this needs a bit of correction, I think, because if you are aligning our document to the RATS architecture, then the relying party will not do anything. It will just forward the evidence to the verifier, attestation evidence, and the attestation evidence from the verifier will extract the claims about the proof of possession of the key. And
that's the background check model.
yeah, and what you are showing, is it
It's all passport model here.
No, in passport model, it doesn't work like that. In passport model, the workload would directly contact the verifier first.
The would do that. The workload first, right? So you generate a key, you include it in the evidence, and you send it to the verifier.
Okay.
Yeah, that's the passport model.
Yeah, the verifier
The
contacts the
verifier, under the covers, goes to the credential authority to compute the credential. So the relying party in this case always, this is, maybe I should make it clear. In this case, it's always the passport model.
Yeah. In this case, the verifier contacts the relying party. Okay, that's
Right.
in the original passport model, it doesn't work like that, but we have tweaked a bit of passport model, yeah.
Just a quick note, you mentioned their workload instance. So again, I think it's the first time you start using it. I think it would be just simpler to just say workload. I understand what you mean.
Do you want to say instance?
Maybe, then just use it consistently. Otherwise, like returns it to the workload instance, introduces a new component. Then you start thinking about the instance where the workload.
Okay, that's fine.
And I think we need to kind of we need to explain this better. Is included in the evidence. The workload verifier verifies the evidence first, right?
Yes, the verifier.
No, we haven't said that. The verifier asserts the trustworthiness, checks the evidence. Once it deems it trustworthy, then it contacts the
the verifier checks the evidence. I just added that.
Yeah. Then contacts the credential authority to compute the credential.
So that's what we're going to do now. We're going to open CAMA. Okay, and I can, let's see if I can just copy it into Mermaid.
Okay, really sorry, I need to run. I will watch the recording afterwards and write the couple of comments.
Sounds good. Thank you.
All right, bye-bye.
I can also devote 10 minutes at least. Yeah, that's fine. Yeah.
Let's see if I can. Is this it? So the workloads, so there are several ones, and I named them in a weird way, but you generate the key, you create credential request, including the proof of possession, create evidence, including the credential request. You go to the verifier, you say request attestation results, you pass this quote as evidence. You compute credential attributes from evidence. You request credentials, passing credential request and credential attributes. I should probably add the check evidence step, right?
Yeah. What I'm thinking is, yours is, it's a hybrid model actually. None of our supported RATS models, the evidence, the verifier doesn't contact the relying party. The passport is acted between only communication between the attester and the verifier, workload and the verifier. Here, your verifier is contacting the relying party because ideally what should you do is that the verifier should return to the workload saying that yes, you are trustworthy. I stamp your trustworthiness, and then that passport should be relayed to the credential authority So that the credential is requested not by the verifier, but by the workload
That's
itself.
a different, but okay, but there are different sequence diagrams.
Okay.
This one, like there are 4 different ones, and in one of them, in fact, that really does happen.
Okay.
So I
But
just
that's
need to,
the full mapping of passport.
yeah. So anyway, I just need to also change this every time.
Yeah. That's the pain with managing diagrams in the code.
Yeah, what we're gonna do. Oh, I need to edit. Oops. Okay, I'm just gonna. What did I just do? Hold on a second. I'm gonna take out this. Put it in there. Unfortunately, this is the pain that we're going to have to live with. Okay, so this is done. So this is the first option. Let me just. So let's just quickly review it before I commit. Any other changes you won't make to that?
No, I think it looks good.
Okay. So then. Right now, I get to commit directly without pull request, which just saves me a little bit of time. Okay, so this auto update, does it save automatically? I don't even know. Okay, all right. So the next option, again, the key source is the workload. So the workload generates its own key, but the credential is obtained from the credential authority. So a proof of possession of the credential key is included in evidence submitted by the workload to the verifier in the evidence. I should probably stay a workload instance.
If you're using instance, use it consistently. If
Yeah,
not,
to the verifier and also the attestation results returned by the verifier. The workload instance sends the attestation results obtained from the verifier to the credential authority, which computes and returns to the workload instance a credential based on these attestation results. So let me see which of the options that is. That's going to be, why I have so many? So I think it's this one. Workload verifier, workload key. Yeah, I think it's this one. So you generate the key, you create evidence, you request attestation results with quote as evidence, you compute attestation results from evidence, you send back attestation results. So I should also check add the step, right? Check the evidence against reference values.
yeah. That would be better, I think. Yeah.
Okay, check evidence against reference values. I just added that. You compute attestation results from evidence, you send back attestation results, you compute credential attributes from attestation results. I don't think that's where it happens.
So
Yeah, no, you create a credential. Here, you don't compute credential attributes from attestation results. You create a credential request. Yeah, so I'm just adding that real quick. You send the credential request. So you convert attestation results to credential attributes, create and sign a credential from credential request and credential attributes, and you send back credential. So I think that's now this is accurate. And this is option B. This is B. Yeah, this is the ones I'm just going to paste. I need to go in here. Paste. Is it still 15 lines? Let me just quickly check. Oh, that's because, there we go. Okay. So I'm committing these.
Yeah.
Okay. So that's the second one. And again, you guys feel free to go in and make changes. Like if I'm not, like if I should mention passport model or hybrid model or somehow, help the reader map it to the concepts they understand in RATs, that would be fine.
Yeah.
Okay. So let's go look at C. We only have two more because that's the most important stuff. So again, so here the workload generates the key, and the credential authority is where you get the credential from.
Yeah.
But it's a different. So although
it's different than relying party and the verifier, is that?
Sorry?
Is it different that the credential provider is different than a relying party and the verifier in your use case? This one, particular one?
Let's see. Proof of possession of credential key is included in the credential request submitted by the workload to the credential authority, alongside evidence destined for the verifier. Credential authority handles the credential request by contacting the verifier on credential authority on workload's behalf, supplying the evidence from the credential request. The verifier responds with attestation results, with the credential authority uses to compute a credential, which then returns to the workload.
Okay, so this is a perfect background check model.
Sure. Yes. Okay, so let's check which one that is. So this is where the workload contacts the IDP, which contacts the verifier. So it's this guy. I need to rename it, but I'm going to rename it.
Yeah, make sure you have crystal clear diagrams associated with each of the scenario. Otherwise, we will have a problem.
These are the diagrams, right? That's why basically I want them converted
in the repo,
to ASCII
in
and
the
placed
repo
in
and
the
the
text.
reference. Yeah.
So like if you see here, it's basically say mechanism A, this mechanism B, mechanism C. So I want in the main the text, this needs to be replaced by some macro that goes renders ASCII.
Yeah.
And this is something I need help with. Anyway, but let's look over this. So generate a key, create credential request, including key of possession, create evidence, including the credential request. And then you request the credential, you pass in quote as evidence. And then you forward the quote from credential request to the verifier. And the verifier needs to check the attestation, check the evidence against the reference value. So again, adding that step. Okay, so it's added that step. And then it says compute attestation results from evidence, return attestation results. And the credential authority converts attestation results to credential attributes. You create and assign credential from credential request and credential attributes returns a credential. I think this is correct now.
Yeah.
Okay, so this would be C. I'm gonna edit it. Okay. Okay, that's done. All right, so we just have two more to cover and then we're done. So there is an option that I called not applicable. And I just felt it was important to include because it's sort of, when you do the mapping of, or the sort of the combination of different options, this one just simply cannot be done. And I just wanted to call that out. So if a workload generates its own credential key, it cannot retrieve the credential from the control plane. And the reason is not a viable option, since a workload that generates its own credential must contact either the verifier or the credential authority to build a credential for this key.
Yeah.
So I'm just explaining, like there's not an option for this, but it's sort of in the sequence. And finally, and again, if you actually look at the all the different combinations, there are more combinations possible. It's just when I look at them, I did let people propose their own, and then we can document them. But this is the last one. So the source of the key is the key store. So somebody already generated the key and placed it in the key store, and the workload gets the credential from the key store and gets the key from the key store and the credential from the control plane.
Yeah, that's a possibility.
Or I can replace that with workload owner. Like we don't need to have control plane as a separate. Like I can simply say workload owner.
But then consistently remove it from everywhere, right? Use a
Yeah.
workload owner for control plane.
How I'll just say here, I'll say the workload owner. I can say via the control plane because everybody understands.
The workload owner is the authority, but the control plane is the medium, is it?
Yeah, but correct. The workload uses the control plane as the medium to do this. Yes.
Yeah, exactly. So you need to be careful that you don't delete it. You have the right thing. You have the link, which is the control plane, but you have an endpoint, which is a workload authority or whatever workload owner.
Yeah.
Right. So don't delete it.
So. Oh no, I didn't delete it. It's just replaced. Okay, so the credential is generated and handed to the workload by the workload owner.
But how and why?
Well,
Just blindly, without any verification.
Oh yeah, yeah. That's fine. Yeah, because again, credential is public.
No, but what is the trust in the endpoint before I issue a workload?
Let's review the sequence diagram and see if that answers your question. Because this is just a high-level explanation. The workload owner stores the credential key in the key store. The workload obtains the credential key from the key store after completing a remote attestation.
Okay. I think we need to review the sequence of this before I.
Well, let's do that. So this is my KMD. Oh, and this one has two steps. Remember how we talked in the reference architecture? There are provisioning steps, and there is the credential acquisition phase.
Okay, so this one has the provisioning phase. Rest all will not have that, right?
Correct. Yes. In the other case, every time you open it, see how there is a credential acquisition phase? Yeah, the other one has a credential provisioning phase. So let's look which one that is. Workload owner. I'm trying to figure out where. Hold on a second. Which one? Let me look at this one first. Credential provisioning phase. Yeah, so this is the provisioning phase. It involves the workload owner, workload, the key store, and the credential authority. So the workload owner creates the workload identity and associated claims, creates the credential key release policy based on workload reference values. Then it goes to the key store and creates the key never leaves the key store unless it's the workload gets it later, right? So this is how you work with the HSM. You go to the HSM, you say, create a key and give me a key handle.
Yeah.
Right. So that's
the key never leaves the key store. That's correct. Workload owner gets the credential first.
Yeah. Or maybe it gets a public portion of credential key. Or key identifier. I mean, I could change that to public portion of credential key or key identifier.
But my question to you is, okay, I have a fundamental question here. Why this sequence is applicable to our use cases? There is no remote attestation here.
No, because this is just credential provisioning. In the credential acquisition, workload will attest.
Yeah, credential acquisition. At the credential acquisition time, the workload will attest. This is a credential provisioning part, right?
Yes.
It is not applicable to our draft, right? Effectively.
No, it is applicable. Absolutely. Yes.
Why?
Because this, without it, the credential acquisition phase is not going to work.
Okay, but this is the initial bootstrap applicable to
That's
all
the
the
bootstrapping.
scenarios.
Yeah, that's the
That-
bootstrapping, but you need to understand the bootstrap before you understand how acquisition can work.
Oh, okay. But then you should be discussing this one in the first, or is it in the first
It
section?
is. So in
Okay,
here
okay.
it says, so under mechanism D, which is what we're discussing, mechanism D consists of a credential provisioning phase followed by the credential acquisition phase.
Okay. My question to you was, the credential provisioning phase is applicable to A, B, C as well?
No, the reason it's not is because in A through C, the workload generated its own key.
Hmm.
So
Oh,
there's
yeah,
going to
that's
be a
true.
unique credential per key.
Okay. Okay.
But in this
Okay.
case, the credential
Mhm.
is shared among a bunch of workloads. This is the horizontal scale out case.
Okay.
And so the workload attestation happens here. So first you provision, then you acquire.
Hmm.
Right? So okay, so just review this provisioning phase, and then we'll go into the acquisition phase.
Yeah. Okay. I think why do you have so much create credential request? Create credential request is coming from the workload
From the key
owner
store
to.
again, because in order to create the credential request, you need to have proof of possession,
Mhm.
and that cannot be done without the key store, because the key store, like the private key, will never leave the key store.
So the key is with the key store, right?
The key is with the key store. It will be given to the workload
Mhm.
once workload attests, but the workload owner never learns the key.
Okay. Where is the key? Where is that sequence where the key goes into the from key store to the workload?
That's in the
Uh,
acquisition phase. It's not
oh,
like this
okay.
again.
Okay.
This is the first
Mhm.
half.
Okay. This is the first half. Okay. It is just getting the credential. I'm
So by
confused
the
with the
end of
word credential request. Why there is so many create? I think we need to reword some of this, right? Because who is creating the credential? Is it the key store creating a credential, or workload creating the credential?
the credential is created by the credential authority always.
Okay, so why you have a create credential request onto key store then?
No, it's not a credential. It's a credential request goes to the key store.
Yeah. The one below what you are showing highlighting. Further down, one below down. It's
You
just
create a
yeah,
credential.
yeah. This is
Credential.
not right, right? This is
It's
a
not a credential request. No, you create a credential request. You receive a credential request.
what is this credential request going
The
to the key
credential
store?
request is like a CSR.
But why your credential request? Because you are saying create a credential for me to the key store, right? That's what your create credential request implies.
No. The credential request it only becomes a credential after you send it to the credential authority.
So create credential request, compute credential request, and sign it with private confidential credential key. Okay. Okay. So what is the act of keystore doing with the create credential request? It is just signing a handle.
Correct. It creates effectively a CSR and signs it.
And then this signing thing is sent to the credential authority. How does the signing thing is it used verify? Or what is the credential authority checking with that keystore
Well,
generated?
it probably checks that it's the workload owner that is asking for it.
But the signature is done by the keystore, right?
The signature on the proof of possession is done by the key store, correct?
Yeah. So what is the use of that? I'm not getting I'm not connecting with this use case.
So the private key will sit in the key store
Yeah.
uh, until ready to release to the workload. But in the
Okay.
meantime, it can be used to sign credential signing requests.
Okay. Okay. I was thinking maybe we can create the name of the message better, create credential request instead of that create credential handle. And that credential handle is compute credential handle and sign with private credential key. And then you pass on the credential handle to the workload owner, and then the workload owner inserts that credential handle in the credential request. Uh, and then how would the credential authority use that handle is not clear to me. The
I
handle
think
which
that's
is
pretty standard fare. Like if I want to
okay.
use a certificate authority
Hmm.
with a signing key that sits in the key store, that's really that pattern. I'm not like inventing a new one.
Okay.
But okay,
Okay.
how about you
Yeah.
take this one on faith? So like I know we're just past the top of the hour, so just want to
Yeah.
really quickly
Okay.
show you the
Okay. The acquisition one is important as well. Yeah.
yeah, so let's go over that. So I'm just gonna go update this real quick because we just made a couple of small changes. Okay, so yeah, so the remaining one is this is the workload goes to the verifier and then from there to the key store. So this is the corresponding
Yeah. The corresponding
this is the
D
credential
scenario
acquisition phase for
acquisition
option
phase.
D.
Yeah.
So you generate an asymmetric encryption key. This is not a signing key anymore.
Hmm.
You generate the evidence, including the encryption key. You
Yeah.
request attestation results passing quote as evidence.
You don't need to write a request attestation result because that is it is implicit. You say that generate quote as evidence, then verify the evidence on the verifier, and then attestation results with encryption key as the result. And then that's it. Attestation results passed
Okay, but that would
to
be a
the key
global
store.
edit across all of them. So again, happy to do that. You can make a comment, but this is
Yeah.
like the substance of it
Hmm.
is that you compute the attestation results, you send the
Yeah.
attestation results, including encryption key,
Hmm.
right? So you're basically saying, yes, I am attesting, I am the verifier, I'm attesting that this workload is in possession of this encryption key. And here are some attestation results.
Okay. Now hear me before we run out of time. Okay, I got it. I got the sequence. I'm okay with this. What I'm saying is I might do one sequence as an example for you because I think it will be too much for me to do all of this before the end of
Hmm.
the week.
Hmm.
So maybe I will try to do a sample ASCII art stuff for one of the diagrams, and then maybe we can coordinate between you, me, and Hank to divide the work, or maybe you have time, you can do the rest.
Yeah, so long as it's a repeatable process, right?
Yes,
Or maybe
yes.
there is a way to do it as a macro, right? So that basically I will say in the main text says this is um uh, this is the file. So then
Mm.
every time it can just automatically generate it if we make a change. That would be ideal.
Yeah, yeah, yeah. Automated should have been helped actually. I don't know whether that automation is going to be there or
Yeah,
not.
well, maybe ChatGPT knows. I don't know.
Yeah, yeah, yeah. We'll see. I'm trying ChatGPT for this. If you find anything,
Yeah,
but
but
anyway,
also
great.
right now it doesn't even compile. So that's like another important part is that it compiles.
Yeah. Otherwise, you won't be able to publish it onto the data tracker before Friday.
Right. Well,
And you are
before
stuck
when
before
is
Monday, actually. Yeah.
Monday? Yeah. Anyway, so I have the weekend to work on this, and I intend to. But I think it doesn't need to be perfect at this point in time. It just needs to be substantial
Yeah.
enough for a discussion at the ITF.
And I think we should try to get it adopted in the ITF.
Yes.
It's a valuable work actually from us. So
Yeah. Well, I
okay.
don't know what you mean by adopted, like as a draft that's worth moving
Yeah.
forward, right? Yeah.
Yes, yes. It's an informational RFC. If even if you don't want to make it as a standard,
Hmm.
but it gives an information to the ecosystem that how attestation can be used to bootstrap workload
Yes.
identity.
Absolutely. Yes, that's
Yeah.
super important. Okay,
Yeah.
so again,
Okay.
thank you so much for your time.
Yeah.
I'm going
No
to
problem.
go and commit the changes that
Yeah.
I made
Commit
here.
everything and then we will see how to polish it, remove the compilation error,
Yes,
make an
please.
ASCII art, one of these. Lot
Yeah.
of work to do, and with other drafts also have to do the same. So yeah.
Yes.
Okay. No worries. Good luck, Mark.
Mhm. Thank you. Thank you so much. Bye-bye.
Bye.
Right. Thanks, David.
No problem. See you next week.
Take care.